Hi friends, today we discuss about the symmetry operation of cyclopentadiene ion. Cyclopentadiene ion. First we see the structure. This is the cyclopentadiene ion. This is carbon number 1, 2, 3, 4 and 5. Okay. Every molecule possesses its identity. So identity operation is present. This is the structure of cyclopentadiene ion. Okay. When you pass the axis from this carbon, this is one, this is second, this is third, this is fourth and here fifth. Okay, that means this is C2. First C2, second C2, third C2, fourth C2 and 5 C2. First we see here, this is the structure of cyclopentadiene ion. Okay, when you pass the axis from the center of this molecule, first this molecule is planar. Okay, this molecule is planar, all the bonds are present on the plane. So this is the planar molecule, and when you pass the axis from the center of the molecule, at that time what happened? The 5 carbons are rotated. That means here C5 is the principal axis. First sentence about the molecule is every molecule possesses its identity. So identity operation is present. Every molecule possesses its identity. So identity operation is present. Okay, second, here see, when you consider this carbon in front of this carbon, there is no same carbon on the same equidistance. So inversion is absent. Inversion is absent. Then third point is principal axis. Principal axis. Okay, here the axis passing to the center of the molecule, at that time number of 5 carbons are rotated. So you have to consider C5 is principal axis. C5 generate C5 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 which is equal to identity. Identity goes to the C5 C5. See here, this is the carbon number 1. When you rotate this C5 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 and C5 that means that C5 is goes to the identity. Therefore, only 4 C5 are present. Okay, then next is the axis related to, see here, fourth point is C2. Okay, C2. C2 means what? You have to rotate the molecule in 180 degree. At that time what happened here? When you pocket that carbon, this is C21 and this is C22. Again you have to consider this carbon C21, C22. Again next carbon same C21, C22. Again this is C21, C22. So here number of 5 carbons are present. So 5 C2s are present here. How many C2s are present? 5 C2 are present. See here, each C2 is passing to the 1 carbon atom and it bisects the 2 carbon atom. See here, this C2 is passing to this carbon and it bisects this 2 carbon. Again C2 is passes to this carbon and it bisects the carbon-carbon bond. Same way, here 5 carbons are present. So first C2 is passing to this carbon and it bisects this bond. Again one C2 is passes to this carbon, it bisects this bond. Again next C2 is passing to this carbon, it bisects this bond. Again next C2 is passes to this carbon, it bisects this bond. And last C2 is passes to this carbon and it bisects this bond. So 5 C2 are present. The next one is the plane. I already told you this molecule is planar. So sigma H is present. And one axis is remaining. The name of that axis is improper axis of rotation. Improper axis of rotation. It's shown as SN. SN. SN means improper axis of rotation. Rotation followed by reflection and reflection followed by rotation. This is called as the improper axis of rotation. Here principal axis is the C5. Okay, when you rotate this molecule, at that time the rotation, after that we get the image, we get the same structure. Okay, so here S5 generate S5-1, S5-2, S5-3, S5-4, S5-5 which is equal to identity. So 4 S5 are present. How many S5? 4 S5 are present. Then next one is the remaining. Here plane is present sigma h. The next plane is the vertical plane. 7 number is vertical plane. Okay. See here, this molecule is planar. That means all the bonds are present on the plane. So this molecule is planar. So sigma h is present in the cyclopentadiene ion. Then next is the vertical plane. What is meant by vertical plane? The plane passing to the center of the molecule and one of the subsidiary axis here. This is the subsidiary axis, that all C2 are called as a subsidiary axis. C5 is the principal axis and the plane passing to the center of the molecule and one of the subsidiary axis. This is subsidiary axis. How many subsidiary axes are present? 5. So each carbon is passes the plane and center of the molecule. So here how many vertical planes are present? 5 sigma V are present. Vertical planes are present. So the total symmetry operations are, see here, identity is the first symmetry operation. Then next is the 4C5. Okay, C5 is the principal axis. Then next is the 4S5. 4S5. Then next is the sigma H. Then how many sigma V are present? 5 sigma V are present. Then next is the, how many C2s are there? 5 C2s are there. So the total symmetry operations are, see here, 1, this is 4, that means 5, 9, 10 and 20. So total symmetry operations are 20. That means the order, that is small h, which is 20. Okay, then classes are, how many classes are present? 1, 2, 3, 4, 5 and 6. Here classes, how many classes are present? You have to write here the classes. Okay, then the point group is here, the principal axis is C, that principal axis is perpendicular to sigma h. So that C4, that C5 get converted into D. So the point group is D5H. So the point group of cyclopentadiene ion is D5H. Okay, this is all about the symmetry operation of cyclopentadiene ion. Okay. Then next is the symmetry operations of methane molecule. Then the next is methane molecule. The structure of methane molecule is, this is carbon, here hydrogen, here hydrogen, hydrogen. That means CH4, this is the structure of methane molecule. Okay, when you pass the axis from this carbon hydrogen, at that time here, this is the again axis, next axis, next axis. Okay, so when you pass the axis from that carbon hydrogen bond, at that time 3 bonds get rotated. So this is C3. Again you pass the axis from this carbon hydrogen, This is C3, again this is C3 and this is again C3. Okay, see the molecule. Okay, this is the molecule, methane molecule. This is one center of carbon, this is center carbon, this is hydrogen, second hydrogen, third hydrogen. When you pass the axis from this one, at that time 3 bonds get rotated, so you have to consider this is the C3. Again you pass this axis from this carbon hydrogen bond, next carbon hydrogen bond, next carbon hydrogen bond. At that time what happened, 3 bonds get rotated or shifted its position, so you have to consider here C3 axis, next C3, next C3, and here next C3 axis. Okay, so the first line of this molecule is every molecule possesses its identity, so identity operation is present. Okay, every molecule possesses its identity, so identity operation is present. Then next, okay, when you consider this molecule, at that time the center of inversion is absent. Okay, see here center, this is the molecule, here carbon hydrogen, here carbon hydrogen, carbon hydrogen. On equidistance, on opposite direction, there is no same atom, so inversion is absent, I is absent. Okay, then next molecule is here the tetrahedral molecule, means what here, this is the age, second age, third age, again then fourth, fifth and sixth age. Okay, so in this molecule, first you see this the structure of tetrahedral molecule. Okay, now the here C3s are present. How many C3 are present? First C3, second, third and fourth. Okay, so the four C3 axes are present. Each C3 generate, here 4 C3 axes are present. So each C3 generate C31, C32, C33, which is equal to identity. How many C3 axes are present? 4. So 4 C3 generate C31, C32, C33, which is equal to identity. Again C31, C32, C33, which is equal to identity. Next is a C31, C32, C33, which is equal to identity, and C33 goes to the identity. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. 8 C3 are present. Okay, first is the identity operation is present, and here 8 C3s are present. Then next is there are 3 subsidiary axes here. Okay, see here the axis along the x-axis, y-axis and z-axis. C2 along x-axis, y-axis and z-axis. Okay, when you draw the axis on this molecule, at that time the C2 along x-axis, C2 generates C21, C22, which is equal to identity. Y, it is related to C21, C22, which is equal to identity. Along z-axis, here C21, C22, which is equal to identity, and that C2 goes to the identity. So only 3 C2s are present. C2 is the subsidiary axis. Then next is the improper axis of rotation. First, thrice C2 axes are passing through the center of the two opposite edges. Edges means here bazu. Okay, when you consider this carbon hydrogen and carbon hydrogen, this is first edge, second edge and third edge. See this molecule. Okay, this is the first edge. This carbon, second carbon, third carbon. Okay, this is the first edge, second edge, third edge. Okay, again here first edge, second edge, third edge. That means 6 edges are present, and each C2 is passing through the two opposite edges. The next is here 6 edges are present, so the dihedral plane is passing to each edge. So here 6 dihedral planes are present. Dihedral planes are present. So therefore 6 sigma d. Okay. Then next is, always remember that dihedral plane is passing to 2 carbon hydrogen bonds. This is the carbon hydrogen bond. This is second carbon hydrogen bond, and dihedral plane is passes through two carbon hydrogen bond. Okay, this is the first one, second one, third one, and again on the same, on the opposite direction, same way the plane passing to carbon hydrogen, carbon hydrogen, carbon hydrogen. So 6 sigma d are present. The next one is the improper axis of rotation. Improper axis of rotation. The symbol of improper axis of rotation is the Sn. Sn is the improper axis of rotation. Rotation followed by reflection and reflection followed by rotation, that is called as the improper axis of rotation. Here again in methane S4 is the principal axis. S4 means what here? There are again three axes, x axis, y axis, z axis. Okay, S4 along x axis, S4 along y axis, S4 along z axis, that generate here S41, S42, S43. See here along the x axis here S41, S42, S43, S44, which is equal to identity. In the same way you have to write along the y axis, along the z axis. But here the point is that S42 is equal to the 1C2, and the same way for y axis, on the same way for z axis, and the last is the S44 goes to the identity and S42 is equal to the C2. So you have to consider C2 or S42. When you consider the S42, at that time C2 is not considered, but when you consider the C2, at that time S42 is not considered. In the same way for y axis and z axis. So here 6 C4 are present. So see here first, second and third, fourth, fifth and sixth. So here 6 C4 are present and the remaining is the C2s. How many C2s are present? See here thrice C2. So total symmetry operations of methane molecule is, see here the total symmetry operations are identity. Then next one is the, how many C3s are present? Here 4 C3 are present. Each C3 generate C31, C32, same way. So how many C3s are present? 8 C3. Okay. Then next is the subsidiary axis, thrice C2 are present. Then the planes are 6 sigma d. Okay, dihedral planes are present. How many dihedral planes? 6 sigma d. Then next one is the, how many improper axis of rotation is present? 6s4. 6s4. S4 is the principal axis. So total is the 9, 10, 12, 12 is 18, 24. Okay. So total symmetry operations of methane molecule is 24. That means the order of the group H is 24. You have to write the classes, number of classes. Here 1, 2, 3, 4, 5. 5 is the number of classes. Then next is, this methane molecule is going to the special point group. This is the example of special point group. The special point group of methane molecule is tetrahedral. Again the same way, when you consider the SF6 molecule, again that SF6 molecule is goes to the special point group. The special point group of SF6 molecule is this octahedral. Okay, this is the related to the octahedral, and when you consider the methane molecule, at that time that methane molecule is going, it is related to the special point group. The name of that point group is tetrahedral. You have to write here TD. TD means tetrahedral molecule. Okay.